Alright, this is the next video in adding and subtracting rational expressions, lesson 3. And I've got two rational expressions here, and what we're going to do is we're going to try to subtract them. Now in subtraction, you are going to have to be careful with, you want to subtract the whole entire denominator when we get to put these together. So just keep in mind that you do need the idea of the fact that there should be parentheses around here because I want to distribute that negative to both terms. Common denominator is going to be one issue that we have, but in the subtraction, this is a very common problem as far as distributing that negative, forgetting to distribute it to both terms. So it might be an issue that you have. So let's look as far as common denominators go. I want to create a common denominator, and I have two pieces that look very similar, but they're not the same. One's got a minus and one's got a plus. So when I create my common denominator, it's going to have this denominator and this denominator being multiplied together. M minus 4 times m plus 4. So I have to have all the pieces from both my denominators in my new denominator. Alright. Now I have to compare. I have this piece that's right here. I need this piece for my first fraction. So I'm going to multiply by m plus 4 over m plus 4. This is really just multiplying by a fancy 1. Nothing more than that. Anything divided by itself is 1. But what I'm doing is I'm going to create something that I'm going to be able to put together. Now, I do have some weird stuff going on here. You can clean this up if you really want to. We're going to probably end up multiplying these together, so I think it should work out in the end, maybe. We'll see. So I'm just going to set them right next to each other. M plus 4 times 1 minus m. Alright, now I am going to have a minus sign in just a minute connecting. Looks like I'm probably going to have another set of parentheses being multiplied, so I'll worry about that in a second. But I know that I have this piece here. That means I need, for my fraction, I need this piece, so I'm going to multiply by m minus 4 over m minus 4. And so when I do that, I'm going to have minus, and I'm going to have m minus 4 times, and I'm running out of room, oh no! Get another sheet of paper, times negative 2m plus 1. Alright, so now that I have everything multiplied together, everything's in one big fraction, I need to focus on the numerator. I need to focus on simplifying this. And I've just been thinking and making these videos about all the reasons why we factor and combine like terms, you know, and add and subtract polynomials, is really to make all of this easy for us. So what we're going to do is we're going to multiply. We're going to multiply here. We'll have to distribute a negative later on. We're going to basically turn this into one single polynomial. I may have to try to factor. I'm going to play around with that when I get there. So I'm going to multiply this. So this is going to be, and I'm going to go ahead and put parentheses around what I get when I multiply this. So this is m minus m squared plus 4 minus 4m. And I'll clean that up in a minute. Over here I get minus 2m squared plus m plus 8m and minus 4. Alright, so all I did was I multiplied these two together and I multiplied these two together. That's just, you know, practicing our multiplying binomials. I'm going to clean this up, combine like terms, get it in standard form. M minus 4m is minus 3m plus 4 minus, and I'm going to keep this in parentheses, negative 2m squared plus 9m minus 4. And I'm going to distribute this negative. So this is really negative m squared minus 3m plus 4 plus 2m squared minus 9m plus 4. And then combine like terms. So Negative m squared and 2m squared is m squared. Negative 3m minus 9m is negative 12m. And 4 plus 4 is 8. Now the question is this factorable? Can I find two numbers that multiply to give me 8, that add to give me negative 12? And just off the top of my head, I'm going to think about it for a second, but just off the top of my head, I'm going to say no. 4 and 2, 1 and 8, yeah, that's not going to happen. This is not factorable. If it is factorable, I should say something like, oh, this is factorable, and I should factor it and see if anything cancels. It's possible nothing cancels. But there we go. There's our answer to example number 3. Again, if we could simplify this, we would. Right now it's not factorable, but that's our answer. We added some rational expressions together. We got them in one fraction. Alright, let's look at this one. This one looks a little bit easier. My denominators are a little bit simpler. So let's look at getting them together in a common denominator. I'm going to create this one a little bit lower here. So it's got to have an a and it's got to have a 2, so my common denominator is 2a. Easy, right? Alright, to make this into 2a, I've got to multiply by 2, but I also have to multiply the numerator by 2. So I'm multiplying by 2 over 2. And so I'm going to distribute that 2, and that's going to be 4a plus 2. Alright, for this one, I'm going to multiply by, I have a 2, I need an a, so I'm going to multiply by a over a, and I'm going to distribute this a. So this is a squared plus 2a. That wasn't too bad. Alright, we're going to focus in the numerator, and we're going to simplify that down. So this is a squared, I like them in standard form, plus 6a plus 2. All over 2a. Now, just like in the last videos, if you need to break this down, you can do a squared divided by 2a plus 6a divided by 2a plus 2 divided by 2a and simplify that if you need to break it into pieces. But as far as I'm concerned, this is great. We know a cannot equal 0, so we're doing good here. We didn't stay our restrictions on that one, that one's okay. Alright, so I've got some other examples. Some of them are tough, some of them are not. Just different examples, but as you go through, you can pause the video and practice and see how you are coming along by yourself.